Hi everyone, super glad to be here. This talk is called View to Pixels 2.0. Reason is that I gave a talk with kind of the same name few months ago in Android Summit and in droidCon London, but this thing is going to be a lot better. No, I'm joking, because today we're going to go a lot deeper into the system. So hopefully you like it. And that's it. I think we're going to just start ahead because there are tons of stuff that we can talk about. Yeah, you can sit here. There are tons of places nearby. See? Okay, so let's just start. Who here likes yoga? Anyone? Yay, I knew I can count on the San Francisco guys. So I've been doing yoga for many years now. I like it a lot. And one of the things I really like that one of my teachers told me, that a yoga, or the reason we love yoga, is that it's kind of like a caress. Because we like it since it's really smooth and it's really continuous. And this is kind of why we love it. And at the very moment it started being like, I don't know, jittery, we feel it so loudly. And we start to hate the whole thing, and everything becomes like just harder, and we just hate it, and we want to quit. So this is kind of the thing I felt about apps, right? About our apps, that we love them so much, and the animations, and when the transitions, when everything is like so smooth. At the beginning, it started to be a little janky. Everything just fall apart, and we really don't like it so much anymore. So in order to have our apps like really smooth as we love them, the first thing we have to do is kind of understand what's going on behind the hood. So this is what we're going to do today. Like I said before, there are tons of talks out there who talk about the profiling tools that we have right now, and tons of talks that are like giving best practices, kind of the same best practices. So today I'm going to dive in a little into what's going on in the system. Hopefully you like it. So I'm Britt. Nice to meet you all. Came all the way from Israel, from Tel Aviv to here. I've been leading startups in a couple of startups already, 3 startups. I've been leading the mobile team off and doing the Android application. I'm also doing communities in Israel, Android Academy community and Women Tech Makers community. But today's story is really not about me at all. Today's story is about love and deceit and despair, about a very awesome dude called the CPU. And his whole mission in life is to get the view, an object that he holds, and find his love, the love of his life, the display, and have the view painted on the display. That's his whole mission. And today we're going to see how it's going to be done. So this, I know, sounds kind of familiar for you, maybe from some other platforms or cultures or other technologies. This kind of stuff is called rasterization. It means exactly that, to take a high-level object that we as developers know how to write and how to read, and turn it into pixels on the screen, on some kind of a screen. So this is what we're going to talk about. Now, as it sounds like, this kind of thing takes a lot of time. It's complex. It's going to take a lot of time to do. And therefore, the CPU needed some kind of an expert to help him with that. So for that, he went all around the city, and there he found some awesome lady called the GPU. It's the graphic processing unit. She's an expert at exactly that. She says, CPU, don't even worry at all. I'm best friends with the display. I know all about her. Don't worry, you just give me polygons and textures. I'll just talk to the display and put the view that you want on the display. No worries. So CPU is super happy, but then he just thinks for a minute and he says, oh my gosh, like polygons, textures, I don't know anything about polygons and textures. I have objects, I have views. Like, where am I going to get them from? So we went all around and he asked his friends. And luckily for him, he had one special friend that is an API, and it's called OpenGL. So OpenGL tells him, listen, dude, don't worry at all. You just give me a list of instructions, the list of the stuff you want me to do. I'll just talk to the GPU. I'll make the polygons for her, everything you need. You just tell me what you want to do. So, okay, seems pretty easy. Seems quite, I don't know, affordable, something that we can do. So this is kind of what we're going to do. Thing is, the display, she's not that easy. The display is like, she's kind of a snob. She has her own time. She has like the time that she wants the apps or CPUs to come and to display whatever they want. So she has this kind of a time, a refresh rate. We have it on, we set it up on hertz. Usually it's 60 hertz, so it means 60 times a second, that there is a new display that can be shown. All right, she has her own time. Now, the CPU and all these guys have to do their best. So for them, there is the time that they can prepare a frame with the views in order to send it to the GPU and to send it to the display and all that. So for that, we call it a frame rate, and this is in order to be like at the time for the display to grab it with a smooth experience. It has to be like 60 frames per second. It means like one frame has to be prepared in 16 milliseconds. And this is kind of the rules of the game. Now, thing is that what happens if a frame takes too much time and a frame CPU did not manage to do all this job in 16 milliseconds? So let's imagine that. We had a frame, like the pink frame, which is fine, it's on the screen, and now the CPU want to get a new frame, like a purple frame. And it's gonna take some more time to make. So the display, like we said, has her own time, and she's going to refresh and show half of the purple display, right? Half of the purple frame, because we didn't have the time to finish the whole thing. So in real scenario, we're going to see something like that. You see the leg? It's like kind of twisted. It makes no sense. So in order to resolve that, to avoid this kind of a situation, what we're going to do is to use buffers. So we don't actually, the GPU would not actually put everything on the display from the top. It's going to first put it on a back buffer, and then we're going to see it on the display. So this is called a double buffering, or actually in Android we have a triple buffer. So it means that potentially we can have two back buffers, potentially. And the way it's going to work is like that. So the GPU, instead of just putting on the frame, the pink frame on the display, it's going to first put it on a back frame, right? And then it's going to switch the buffers, and the frame buffer is exactly what we're going to see on the display. So everything's fine. Now we're going to take the slower frame, the purple frame. We're going to stop at the middle, right? Because we didn't have enough time to do the entire frame. So we're going to stop. The back buffer is going to stop at the middle, but the refresh took the frame from the frame buffer. So it all fine. So we had we've seen the pink buffer, the pink frame for more time than we expected, but it doesn't matter because at least it makes sense. So only when we finished with the purple frame on the back buffer, we're going to switch the buffers, and the frame buffer is going to be the purple one on the display, and we won. So this kind of thing is called a VSync. It's vertical synchronization. Vertical because the GPU just fills the pixels from top to bottom, so it's like vertical. This is the way it is called, and this is kind of the sign for the display to actually say, okay, I'm ready for a next frame. Right? So let's dive into a little more details. So like I said, vsync is the time where the display is ready for a new frame. So when this happens, what the CPU wants to do is to measure up the view that he wants to put on the display at the end of it. He needs to figure out first what's the size of the thing we're talking about. So he's going to measure it, figure out the size, then he's going to prepare a layout just to understand the position of the view. Where is it going to be on the display? Next thing, we're going to draw. So it's not really to draw yet on the display. We first, like we said, we're going to prepare the display list. And after that, we need to, what do you think? What do you think we need to do? To send it to the GPU, right? So we need to somehow upload the display list. The display list, the bitmaps, everything has to be transferred to the GPU so we can use them as they're going to be transferred as polygons and textures, like we said. And then the GPU is going to execute it, but it's going to execute it on the back buffer. Then we're going to switch the buffers. And then it's just going to be displayed on the screen. And that's what we wanted. We won. Happy? Yeah, OK, good. So this is kind of the steps that we saw right now. One thing that I did not mention is that we're talking here about an app. So an important thing we do with the app is interacting with it, right? Which is really important. The user has stuff that he wants to do. So we do have some steps before. The user is the most important thing that we want to treat, right? So his input, like the buttons he clicks on, the edit text, the switches, everything that the user does, it's the first thing we want to treat. So all of those things, all of the callbacks that you write, your own click listeners and everything like that, is going to be the first thing that will be processed. So this is the input stage, and many times the inputs, obviously, they trigger some animation. This is like our way to tell the users, we got your input, right? If you click on a button, we have some kind of animation, maybe a ripple effect or anything like that, a change of colors. So many times there are animations. So the second thing we want to do after the input, we're going to process the animation, calculate everything that needs to be there, and do all the callbacks and everything like that. And only then we're going to start with the measure and the layout. Usually the animation, or I don't know if usually, but many times the animation actually changes, right? The measurement, the layout, stuff are moving around, changing colors. So we first want to do the input, the animation, and then we're going to measure and layout and everything. So this is kind of the process, which is really important. But I want to go a little bit deeper to what's going on there. So as you know, when an app launches, there is a dude, a service, a system service called Window Manager, who knows everything about all the windows. So he understands, OK, I have an app. The app has views, right? So the app has views. I need to prepare a window for it. A window is just a container of views. He needs to prepare a window for it, but the idea is not the window, right? The idea at the end is going to be the display. So the window manager, like I said, he knows everything about the sizes of the view, about the views in the windows, of course, the life cycles, input events, positions, the Z ordering. He knows all about those for all the system. He grabs all the information about the window that we need to prepare for the new app, right? And then he's going to go and, well, he needs to find somehow a surface, a place on the display, right, for the app. So what he's going to do is going to go to a guy called Surface Flinger. So Surface Flinger is, once again, a system service, and his, it's like the big brother of the display. Only him can change the content of the display. So if anyone needs a surface, he's going to go and get it from him. He knows all about all the surfaces on your display. And what do I mean when I say all the surfaces? No, there's not only one. If you think about it, yeah, there is the surface for the app UI, which is the first one we think about, obviously. But for example, on this screen, there's also the status bar surface, which is a whole other thing, refreshes and changes animations and content at his own phase and at his own time. So there is the status bar and also the navigation bar. It's also a surface. So the surface flinger is the one who knows all about those. So Surface Flinger is a very tough dude. Window manager goes to Surface Flinger and says, listen, dude, I have a new wooer for the display, a new app. They need a window. He needs a window. He's going to go and do a crazy display, a nice display. You want to give him a good surface. So he asked for a surface. You can give him all the metadata because we said that the window manager knows all about it. So please give me a display. So Surface Flinger, a very tough dude, says, OK. All right, so he prepares a surface for him. The surface contains a buffer queue. A buffer queue actually is buffer pool, which is just the graphic buffers for all the graphic data that the surface would need. The one who is in charge of the allocation is the Barak allocator, who is on the hardware abstraction layer, meaning it is vendor specific. So we're just dealing with the abstraction here. But he's in charge of allocating the memory. And we have the queue, the actual queue for the buffers, like we saw before, with the frame buffer and the back buffer and all of those. So he has the queue and the logic for that. So window manager needs to go back to the app and tell him the news. So he's going to say, well, listen, I got you a surface, right? I got you a surface. But it's on a different process. I'm sorry. You can't really talk to him straight to him because that's not what we do in Android. We can talk just like that between surfaces. So what I'm going to do, I'm going to give you a binder object, and you're just going to talk to him. Don't even worry about that. So app is really excited. He doesn't even care about that. And once you have a new display, you're just going to go to the binder with a buffer queue and says, listen, I have a new display. I need a frame. I have a new frame that I want to present. So buffer queue is really excited and is going to search the queue for a buffer that is not being used right now because we don't want to give him something that some other people use or something that we see on the screen right now. So he searches for a free buffer and he just hands it to the app. And the app then can just put in all the graphic information there, color it, for example, and then just bring it back to the buffer queue with a signal that says, OK, I'm done. This is something that needs to be displayed. Take. Awesome. No buffer queue holds this buffer. And then the display wakes up, because she had a vsync, so it's a good morning for her. And she says, OK, guys, listen, I'm ready for a new frame. Bring it on. So Surface Flinger is a very tough dude. So he listens to her. And what do I have to say? OK. So Surface Flinger now goes to all of the surfaces, right? We saw that he has many surfaces, not only the apps. He goes through all of the surfaces, through all of the buffer queues. And he asks each buffer queue, OK, do you have a new buffer for me? If yes, he just takes it. If no, then he uses the first one, right? We saw on the vsync how it works. So we have those. And, well, he has lots of stuff to do, Surface Flinger. He doesn't really gonna compose everything right now. So we asked for a friend, a hardware composer, also an abstraction from the hardware abstraction layer. So once again, he's talking to an abstraction and something that is very vendor specific. But then anyhow, all of the buffers from all of the surfaces goes to the hardware composer, and he decides how to arrange them, how to compose them, and he sends them to the display. And we can present that. OK, awesome. So let's talk a little bit about more of what it is to create a frame. I think that many of that is kind of familiar for you. So we talked about these steps. I'm going to show you this slide a couple of times more. And let's see what's going on a little bit about the CPU stuff. So first of all, I want you to know that there are many steps here, right? And we have to know that the order of everything is guaranteed. So it doesn't mean that we always have an input event, right? Sometimes we don't. And we don't always have animation, and we don't always need to redraw a view. Of course not. But if it's going to happen in order. So that's the first really important thing. The second thing is that each step is called up to once per frame. All right? So if you called, for example, if you had implemented your own view and you called for some reason invalidate 5 times, it doesn't mean that it's going to actually invalidate 5 times. It's going to only happen once. We're going to redraw only once. So this is also something that is kind of important to know. Well, how does this happen? We have a really nice lady. She is the choreographer for all of those stuff. You probably know her. She was probably yelling at you once or twice on the logcat, right? That you missed frames. And let's see a little bit like what's her story. So a quick reminder. It's not, yeah, you know her, I know. a quick reminder, because it's not really about that. I'm sure you know that when we launch an app, then Android's going to create a process for us, a Java process for us, with a thread that is going to be our main thread, our UI thread, the only thread that can touch the UI. So the UI thread, you all know that, is really busy. Has tons of stuff to do. So yeah, all of the UI drawing and all of the UI stuff that we're talking about here is going to happen on the main thread, but also the services and the input events and the, all the application callbacks for life cycles, everything is going to happen on the main thread. You know that stuff. You know that the main thread is super busy. Now, threads in Java, in general, when we start them, they have the run method. The run method runs, completes, and then they die. So that's awesome and all, but we can't have the main thread die without us just killing the process. We cannot have it happen. So what we're going to do for that, we need some kind of a loop, right, to keep it alive all the time. So we actually have a specific person who's in charge of this kind of loop. He's called the looper. Makes sense. And he holds the message queue with all the tasks that we saw before. He has this message queue that he needs to, is going to just run through them, schedule them, run through them, just make sure that everything happens on time. So we have the message queue. Now we need to contact the message queue and push messages to it and handle the messages and these tasks when we need to. So for that, we have a handler that does exactly that. He knows how to send messages to the queue and how to handle these messages to the queue. Now, the looper, we have to have one of those, right, per thread. Makes sense because we need to, everything happens sequentially. But for the handler, we actually can have multiple handlers that know how to do different stuff, and they all connected to a specific looper, and they can just give him messages and receive the messages for the right object. So that's kind of what's happening with a choreographer. A choreographer is attached to a looper, to the main thread looper, because this for each looper thread, they're going to have a choreographer who is attached to the looper, and is going to have his own frame handler. This frame handler is going to do all the stuff that has to do with the frame, like you see do frame. Let's see what do frame does. Just goes through the callbacks of the different type of tasks that we talked before, like input, animation, traversals, all those, and it just do the callbacks of those. So you can see from here, you can see that the order is guaranteed, like I told you. And each step is going to happen once. What's going to happen in the do callbacks? So for each type, there's actually a callbacks queue with all the callbacks per type. So it's going to grab all the callbacks per specific type, and then just going to run through them and just run them, run the callbacks per type. So this is kind of how it works. Awesome. When we saw the traversal type, it means those steps that we saw before: measure, layout, and draw, which are all of the, like we said, measure is about figuring out the size, layout is about figuring out location or position, and draw is to draw or to prepare actually the drawing instructions for the views. All of those are going to happen in a traversal on the view hierarchy. So we're always going to go up to the top, and each view is going to go down the hierarchy, say what it's looking for. So for example, the measurement would go to the children and say, hey, child, how big do you want to be? And he's going to give his own instructions, I guess. You can be up to this size, but how big do you want to be? And each view is going to go down the hierarchy and ask the other ones, and ask the other views. Same goes to layout, pretty much, about positions though. And the draw, we're going to go all the way down as well. Now, originally, I mean, in the previous talks, I went through some best practices here and how to make stuff more efficient, like with the layout and the measure. And I felt like there are tons of best practices, like I said, that are out there from previous talks, from the blogs out there, actually from the documentation right now. They added very recently, they added like best practices for how to handle slow rendering. So and the constraint layout, of course, that is meant to address those issues, to make the measurement and the layout more efficient. So what I'm going to do now today is to talk a little bit more about the draw part. I'm going to talk a little what's going on there, and to talk about a little more stuff that, wow, we have time, I'm super happy. And to talk a little bit about stuff that maybe can help you, like maybe ideas, maybe stuff that you didn't know when you create your own views or draw yourself. So a draw method on a view does something like this. Well, it takes a canvas, as you probably know, and is going to go pretty much on those stages. So first thing, we're going to draw the background of the view. Second thing, well, I'm going to say that we're going to draw the background of the view. This is the reason that many times when we talk about performance, and the best practice says that if you don't actually need a background, don't just set a background. So this is kind of for that, because we're going to set the background anyways. I mean, it's a layer, right? It's a layer, and we're going to draw it first, no matter what. And step 2 is just optional. It's if we want to later have some fading, like some shadows and stuff like that on the view. So we first need to save the layers, means save the state of the view right now, what we drawn so far. Then we're going to do the on-draw. So the on-draw is what you override when you create your own views, for example, and they're going to just do the content, draw the content of the view. Next thing would be to draw the children. Told you that we're going to have like a pass on the on here too, on the view hierarchy. So this is also, we're going to draw all the children. And then if indeed we needed the fade before, we gonna prepare a shader. We're gonna talk about it a little bit in a few minutes. So we're gonna create a shader and then just draw it. So it draws the fade effect, and then restore the layers if we need to. Then we're gonna draw the foreground. If you set up a foreground, or sometimes for lists we have the scroll bars and everything like that. So this is more layers, another drawable that we're gonna draw. And next thing, we're gonna draw default focus highlights on the canvas. Once again, another layer. So it's just an examples, everything we saw so far, all of the methods behind like the name, they're gonna do pretty much that. They have a background is just an example for a drawable, and we're going to draw it on the canvas. So each of these is a layer, right? Each of this is a layer, and it's going to do like one on the top of the other and the top of the other. So it's just pixels that we have to paint. Hopefully you know that there's a very awesome tool, which is the GPU overdraw tool that you can, on the developer settings on your phone, on your actual device, you can set it up. And then here, everything is white, but I drew some objects here. And just once I turn it on, I'm going to see so much colors that would indicate how much overdraw did I have. So looks like I deleted the numbers, but you can figure out that the blue one is if I drew 1 pixels on top of the other. Then we have the green, which is 2, and then the red, which is 3, and the darker red is 4. So it's going to show you how many layers did you paint one on top of the other. To avoid that, you just have to not draw them. Right? So we have the clip rect, or on the on-draw, we have to like do all kinds of stuff, or to, like I said before, for example, on the background, maybe if we can not do the background drawable, and this is the stuff that are gonna fix this situation. So let's talk a little bit more about the canvas and what's going on there, and how is what we write on the canvas. Well, actually, it's going to be at the end of the stuff, OpenGL commands, of course. So first thing the canvas is going to take care of is all the primitives. So we have the draw path and the draw oval and draw rect, which actually both at the end are going to be figured out as paths. So at the end, everything is going to be paths. And the path, second thing the canvas is going to do is to figure out path effect. You also can add path effects to your, when you draw the paths and the primitives. And what it has to offer us is like something like that. The strokes, the corner effect, anything like that. So you can use actually those to create the dashes and everything that you want. So this is the second thing. It's going to figure out the path effect. Then it's going to figure out the alpha. So this is kind of to understand. It's going to create a mask and understand which of the pixels we're going to actually draw and which we're not going to draw. Okay, which are actually on the bitmap itself and which are not, and which is going to be kind of in the middle if they have like a certain alpha in them. And it's not totally opaque and not totally solid. So next thing, and we saw it a little bit before, is the shading. And it's about determining what is the color of each pixel. So if you did paint set color, for example, this is like the simplest shader that are there, right? It just sets a color, a specific color for all of the paint. This is about set color, doing something more I don't know, crazy, is the color filter, which you give them a matrix, and paint set shader is what we used before, if you remember, on the draw. we created a shader, and we draw a rectangle with this shader. So this shader that we're using on the draw for the fade effects is the linear gradient, but there are tons of other stuff that you can do. The bitmap shader and the gradient, the radial gradient, lots of stuff that you can do actually. Actually, I think the time I learned about shaders was a couple of years ago with junky lecture. I put there a link to that, so you can learn a lot about shaders and color filters from them. And next and last thing we're gonna figure out, the canvas has to figure out, is the transfer. So it means how to transfer the pixel that we just chose the color of and that we made sure that is not transparent. How do we need to transfer it to the bitmap that we're gonna end up with? So to do that, we're gonna use a transfer mode. The way it works is that there is a source image that we're gonna paint, and there is the destination image that we're gonna end up with. And we're gonna just have to decide upon a transfer mode. The way we do it is with portrait of modes. There are tons of them that you can use when you create your own views, for example, and you decide how to draw the stuff, how to draw the images one on top of the other. So there are many stuff that you can define about the alpha of those, and also about how to integrate them, to have the pixels added, the colors added to one another, or multiply, or many other stuff. I can say that for me, the most practical, or I used it the most when I needed to load an image, and maybe you do it on your apps too, to load an image on a specific shape. So this is kind of stuff that I think is like very, very useful. And using the shaders, using the transfer mode just gives it for us really, really, really easily. So that's also something that can be useful for you. Anyhow, whether if you choose to use the canvas, using the canvas meaning to use the views that you created, with the Android just gives us, you can use the canvas, or you can use just OpenGLES and write commands yourself. At the end, everything is going to be OpenGL commands, translate to OpenGL commands, and all of them are going to be rendered into a surface the same way, and sent to the buffer queue, like we said before, and will be used by the surface flinger. So this kind of doesn't matter which way we choose to render, it's going to end up the same way. This is, once again, the steps that we saw before and we talked about before. I'm not going to talk about, like I said, so much of like profiling tools that we see all the time. I do want to mention two small stuff, and this is the reason that I chose those colors and those the naming and the ordering of stuff. Is first the GPU profiling tool. Once again, a tool from the developer options on your device, which is very, very, very handy. What it does for each surface, you see there are a few surfaces here. It gives us the situation for the GPU steps that we talked about before. The colors are the same colors that we talked about. The steps are the same steps that we talked about in depth, so hopefully it would make more sense for you today. And also, since Android N, there are the frame metrics that you can use yourself. They are using the vital dashboards and so on, some of them aggregating for you, but you can also use them yourself, and just if you want a specific stuff to check specific things for specific frames, you can actually do it. You can use, this is from the documentation, I don't expect you to see. The thing is that the constants that you can use in order to do this profiling are the same stuff that we talked about, the vsync, the input, the draw, everything is the same stuff we talked about within this order. So once again, hopefully it makes more sense for you today. So we actually finished on time. I want to thank you so much for listening to me up until now. I don't know if you have time for questions, but I'll be here anyways. And thank you so much, and keep in touch.